So we're going to start off with some of the advantages and disadvantages of stick welding. Why would I choose stick welding over any other process? I can run flux core, I can do TIG, I can do gas metal arc welding, solid wire. I mean, there's a bunch of various processes that I could run. Why would I want to run stick welding? So for starters, stick welding is great for field applications. Okay, if I have big structural connections or out on the pipeline, stick welding is a great alternative to run in some of the other processes, just for ease of use. Okay, I have very limited components with this. I have a power source or an engine drive machine. I have a workpiece clamp or ground clamp, and then I have an electrode holder. That's it. I've got 3 basic pieces. Okay, so ease of use, simplicity. I can also weld in windy environments, whereas if I try to use gas metal arc welding, 30 feet up in the air with 20 mile-an-hour winds, that's not going to work out so well, right? It's going to be full of porosity. I get good weld deposition with this, right? So with stick welding, we get good deposition rates, good depth of fusion or penetration. Repeatability is another thing. So if you look at the AWS D1.1 structural steel code, shielded metal arc welding is pre-qualified because it is proven time and time again to be effective. So what are some of the disadvantages? Well, I think shielded metal arc welding is about 60% electrode efficiency, right? Meaning I'm losing about 40% of that electrode to slag, weld spatter, right? Things of that nature. A little bit of weld spatter. So I mean, there's some drawbacks. It's a slower process, right? Compared to other processes, because every 6 or 7 inches, I have to stop, I have to chip it, I have to clean it. I have to do a lot of base metal preparation because, especially when we're dealing with low hydrogen electrodes, they like clean material, right? Anybody ever weld on nasty, see this guy's shaking his head. You guys ever weld on nasty material that you didn't take the time and do a little bit of base metal preparation, and you wonder, why didn't this weld turn out like I thought it was gonna be? I mean, it's definitely not Instagram worthy. How do I fix that? Base metal preparation is gonna be a big key component to that. So let's talk about the equipment, and hopefully I won't get any feedback. Andrea is going to be doing all the welding demonstrations, so we're going to go through, talk about the system, some of the components to it, how to operate it. She's going to do some demonstrations. We're going to talk to you about how to find the right amperage for the electrodes that you're working on. So today we're going to be using these new ESAB 7018-1 prime electrodes. Has anybody used these yet? One guy, 2. Okay, so if you have not had a chance to use this, if you're a stick welder, I was a big fan of another name brand electrode for a long time until I got one of these dropped in my lap. These things are amazing. Anybody ever stick a welding rod? Just same guy. So if you've ever stuck a welding rod trying to initiate the arc, try these out. I kid you not. I don't know, they got some black magic on the end of this thing. It just does wonders. They start off really, really nice. I don't want to put you on the spot. All right, so we're going to go through some of the components. Obviously, we have our power source right here. Today, we're going to use the 205 IC. This is for AC and DC. So you can run AC 7818 electrodes. You can run DC. You can run all different types of welding rods. Pretty much whatever your heart's desire. So we're going to start off with the electrode holder, or stinger, or whip, whatever terminology you're more accustomed to. If you notice on the inside of that stinger electrode holder, it actually has grooves, so you can move the electrode in whatever position you need to get into whatever type of joint you're welding in. So when I go vertical and overhead, I'll put it in the jaws differently than I would put it in the flat position. Now, because we're using 7018 rods, which is a low hydrogen electrode, right? We're going to use that on DC positive. Okay, so DC positive. So that, or electrode positive, that means the electrode portion is going to be plugged into the positive receptacle on this machine. The workpiece clamp. A lot of people refer to this as a ground clamp. There's actually no grounding being taken place. This is just completing the other part of the electrical circuit. So this is a workpiece clamp. You can still call it a ground clamp. We're going to plug this into the negative side. Now, if we switch polarity, why is polarity so important? Anybody know? You can't raise your hand. You got an idea? So with this, what this designates is the flow of electricity. So think of the battery in your vehicle, right? Electricity is going to flow negative to positive in a DC circuit. So when I plug this into DC positive or electrode positive, 70% of that electrical circuit, or 70% of that heat, is actually on the electrode. The other 30% is on the base material. That's why if you ever notice when you run flux core wire, you switch your polarity. For flux core self-shielded wire, you're going to switch your polarity. Most of those are going to run on DC negative. Okay, meaning 70% of that heat is now on my workpiece. The other 30% is on the electrode. Anybody ever done TIG welding before? A lot more hands. Okay, so what happens when I run TIG welding on DC positive? You're going to melt your tungsten, right? Right? So, and that's because the arc that you're dealing with is roughly 10,000 degrees Fahrenheit. Now, tungsten melts around 6,280 degrees. So if I put 70% of 10,000 onto my electrode, or my tungsten, I've already exceeded that melting point, right? So same thing. I need to switch that to DC negative so that I have 30%, or roughly 3,000 degrees on that tungsten. You'll quit melting your tungstens that way, and it's an easy way to remember where to switch your machine to when you're getting set up. Okay, so now let's talk about this rod. So 7018 is low hydrogen electrode. We've already established that, and the 8 at the end of that 7018, that's the designator that tells me that it's a low hydrogen rod and should be run on DC positive the majority of the time. You can run these rods on AC. So what DC positive is going to give me, it's going to give me a deep, wide profile of a weld. If I switch to straight polarity, I'm going to get a narrow, wide bead profile. I don't want that. That's lack of penetration. AC is about 50-50. You kind of get a shallow weld profile, a little bit wider bead, but DC positive is probably going to be your best bet. Now with 7018, because it's low hydrogen electrode, it usually comes in these vacuum sealed packs. Thank you. So these are vacuum sealed packs. You should probably burn this up in about 10 hours. Okay, so try to use those up or put them in a rod oven. We put them in a rod oven to keep the moisture out. How many of you guys have a refrigerator at the house with a 60-watt incandescent light bulb in there, and you say, I'm keeping the moisture out? Good answer. Okay, because if that oven's not, or that your refrigerator with that 60-watt light bulb in there, if it's not hitting a minimum of 250 degrees Fahrenheit, you're getting moisture into your electrodes. You're going to develop porosity, you're going to develop hydrogen under bead cracking, and you don't want any of that, especially if you're dealing with structural applications or thicker materials. Okay. Now, this whole process, shielded metal arc welding or stick welding, is DC constant current, meaning, and you can watch, as Andrea's welding, you can watch the digital readout on the front of this machine. So if we set that machine at 100 amps, it's going to remain nearly constant. Voltage, however, is going to fluctuate. The voltage is going to fluctuate the closer or further she gets away from that puddle. Okay, if she starts to pull back too far from that puddle, the voltage is going to jump up. The current's going to remain nearly constant. Okay, now conversely, if we go to gas metal arc welding, that is a constant voltage system, meaning that the voltage is going to remain nearly constant and the amperage is going to fluctuate depending on your contact tip to work distance. As you pull further away, you're going to decrease your amperage. As you get closer, you're going to increase your amperage. If you don't believe me, watch the front of your machine, right? That's where you're going to get all your heat from, is your wire feed speed. A lot of people say, hey, you're running too cold, you need to turn your volts up. That's just going to give you a wider puddle, okay? Because voltage is the electromotive force of that arc, right? So we're going to talk about exclusively today the 7018, but we're going to talk about 7018 and how to figure out the amperage range for that. Now on this pack here, sorry, on the back of this thing, it gives me some parameters, okay? It'll run AC or DC, 110 to 140 amps, okay? So that's a pretty big, jump. So how do I know which amperage to use for what position that I'm going to be working on for the thickness of material and all that stuff? Well, with low hydrogen electrodes, any low hydrogen electrode, so it doesn't matter if it's 7024, 7028, 7018, 7016, 8016, you can use the decimal equivalent of that rod. So this is an 1/8 inch electrode. If we just take 1 divided by 8, that gives us the decimal equivalent. So that's a good place to start. So we're going to go ahead and we're going to start off with 125 amps in the flat and horizontal position. Now once we start going into different positions, we're going to go ahead and give you some more math and show you how effective that is on vertical and overhead. Okay? Everybody ready? Everybody ready to watch Andrea weld? So we're going to go ahead and select stick. Got our polarity set up correctly. We're going to go ahead and crank it up to 125 amps and turn the output to on. Okay, that's like a safety switch. So this turns red, you're ready to go. So she's going to go ahead and get this tacked up. We're also going to talk about arc force, and we're going to talk about hot start momentarily. We're going to kind of give you a little bit of in-depth on that, because you've got all these fancy features and functions on your new welding machine. It'd be really nice to know how to understand, you know, exactly what those do and how to operate those efficiently. Okay, so for those of you that are in a good position to see, watch the front of the machine as she's welding. Notice that the A over here, that's the amperage that you're going to be operating on. It should remain relatively close to 125 amps. That initial jump up where you see that 145, that's what's known as your hot start. So if you have problems with sticking your rod in the beginning, you can turn your hot start up. What that is a momentary increase in amperage to help you get that puddle established. If you don't have hot start, sometimes it can be a real pain in the rear end to get that rod going, and once it goes, it's just fine. But it only happens for about a half to 1.5 seconds, right? We're just going to jump up and spike a percentage. So let's say you have 10% arc force. You start off with 100 amps. You're going to start off with 110 amps. Okay, so it's just 10% of whatever you set your machine at. So we're just using 100 because everybody can do 10 math, right? So it's very simple to operate that way. Now arc force, what arc force does is the same thing. As that puddle gets closer, the machine's going to understand, hey, my voltage is getting smaller, because as I get closer to that puddle, the voltage is going to start to drop. That machine says, hey, if it drops far enough, it's actually going to stick. So what the machine does internally is it increases my amperage, that known percentage, to give me a hotter puddle. Okay, so it's just a momentary increase in your amperage as you're welding to help you prevent sticking. So again, this is one of the disadvantages of dealing with a 7018 or stick welding in general. You have to chip your slag, you have to wire brush it, you have to get rid of all that stuff. It's a pain in the butt. And you got to keep it clean. If you try to weld over top of that, you're going to trap slag. Okay? You're going to trap slag, your x-ray's not going to shoot, that's not going to work out well for you. Any questions up to this point? There's a lot of information to digest. We'll just take little questionnaire breaks. And then if you guys have questions you don't want to ask in front of everybody, feel free to stop by after the show. Come up and talk to us. Be more than happy to answer any questions you might have or give you recommendations on any types of products or equipment that you suit your needs. That falls under low hydrogen, which makes it good for structural steel applications. But then you can get into F3, F2, and F1 classifications. So your 6010s, 6011s, 6022s, those are going to be really good. They're going to fall in the F3 classification for fast freeze. So that's why a lot of people use them on the pipeline, because you have an open route. It's going to solidify without over penetrating. Yes, I've heard tell you can run 7018 on open route. I've never seen anybody do it successfully. I'm sure that there are people out there that can do it, but for repeatability and speed, they typically run a 6010 because of that open route. You can kind of judge that depth of penetration to where you're not over penetrating that material. Your F1 classifications are typically your fast fill. So like 7024s, 7028s. 7028s also going to fall into a low hydrogen, just because the iron powder that's in the flux that kind of helps for bead appearance and deposition rates. But anybody ever run 7024? Okay, you're putting down some serious metal in the flat position, filling thick material up rather quick. Your F2 classification is going to be your fill freeze type rods. Those are good for sheet metal. So like your 6012s, 60. Now I'm drawing a blank here. 6013s. There we go. I should know that. We just ran that over Good Land Fest in Texas. All right, so here's the typical flat bead. Good bead profile, smooth bead appearance. That's another reason that they add that iron powder into the mix of your 7018 rods. Bead appearance and deposition rate. So you actually have some of that metal powder that's baked into the flux that's going to help with those two items. right, so we're going to go ahead and we're going to do some simple math. So this would cover flat and horizontal, 125 amps. Seems like a good place to start. Andrew didn't have any problem with that. So let's go into vertical. So if we go into vertical, we want to figure out 10%. Okay, so we just take that 125 amps, right, and we just multiply that by 0.90. That gives us roughly 112.5. So we'll go like 114 amps. We can just round up, 110, 115, somewhere in there. So we'll go to like 112. So she'll get another piece tack, or actually you can just weld the other side of that coupon. We'll just go into the vertical position, and then we'll do the same thing for overhead. It's pretty simple math. I know welders don't like to do math, guilty as charged, but it's actually practical and it comes in handy. And everybody says, well, what happens when I'm running half-inch plate? You know, is that same rule going to apply? Yeah, I've ran 1-inch plate certified through the Ironworkers Union using this same method, right? Ran 118 amps overhead, 1-inch plate. It's beveled, so you have to think about it as when that material is beveled, it's actually thinner at the root, right? It's no longer 1 inch, right? I've got a 0 land on there. You know, the plate's practically an eighth inch thick. Put about a 5/16 gap in there, and you're just running multi-pass welds the whole time. So it gives you a little bit more control, a little bit more stability, keeps the sparks off your beards. You can relate, right? You don't want sparks on your beards, right? That hurts. Especially on top of the head there, right? You don't want that stuff. So if I crank it up too high, I start losing control of that puddle. This gives me a little bit more control. I've ran the same process, passed x-rays, passed bend tests. You shouldn't have any issues. Your material thickness is going to be, or your welding rod diameter is going to be based off the thickness of the material. So anything I would say 3/8 or larger, I'm going to jump right up into an 1/8 inch material. Now if I'm not running beveled plate, if I have something bigger, I'm going to go to a 532, right? Use a 5/32 electrode. Well, guess what? Same principle is going to apply. How do I run that in the flat position? 5 divided by 32 gives me about 165 amps. Somebody can check my math, call me out on that. But it's going to be the same place. It's going to be a good place to start, and then you can adjust from that position, up 5, down 5, wherever you like it. But it just gives you a good place to start, good rule of thumb. Ready? All right, so she's going to go ahead and run a vertical piece for us. So you can see initially how easy and smooth that 7018-1 prime lights off. I want to say that they have graphite on the tip, and that's what helps that arc initiation process, but it's very smooth. If you guys haven't tried it, I definitely recommend stopping by the General Fabrication Zone. I think they have some over there that they're running. It's a very smooth rod. Anybody coming back this afternoon at 3 o'clock for the D11 class? We're going to be running D11 plates. Oh, I hope you'll be here. Somebody's got to run the camera. We're going to run a 3G and 4G demo this afternoon. Regular AWS D1.1 standard. So if you're in class right now trying to pass that test, you're in a job, getting ready to take on a job, you have that test, stop by at 3 o'clock. We're going to be running that test and show you exactly how to walk through that. We're going to be using the same setup. Right, so if you take the basics class, we're going to go one step further and show you. I would actually use this on an actual test. Okay, so for welding qualification, we can talk about joint fit up, joint prep, all that good stuff that goes along there. Hopefully, give you some little tips and tricks that's going to help you along your way. Some things you want to consider when you're going ahead to take a test. While she's cleaning that up, we'll go ahead, we'll figure out what the overhead is. So if we figure out you have 125 amps for flat position, I'm going to use my calculator now. It's not much. You end up with about 116 amps. So we take 125 times 0.95, it's going to give me 118 amps. So we'll adjust this right down to 118. Because I think like 110 is a little too cold for overhead. Contrary to popular belief, people think that, oh, I'm going overhead, I want to turn that down even more, right? No, you want to turn that joker up. Welding overhead is not difficult. It's very similar to welding in the flat position. You're just welding above your head. Everything else pretty much stays the same. Travel angle, work angle, all that stuff's going to stay the same. So we'll give her a couple minutes because she actually has to attach the piece to the overhead compartment, or the overhead little fixture that we built for running overhead over here. That way you guys aren't getting arc flash. Try to keep everything below the screen. So right now she's going to go into a 4F position. So 4 meaning, so the basic joint or the basic position types are 1 is going to be your flat, 2 is horizontal, 3 is vertical, and 4 is overhead. So if we're running a fillet, it's going to be 1F, 2F, 3F, 4F. If we're running a groove weld, 2 plates with a backing strip, you're going to have 1G, 2G, 3G, and 4G. Now those same positions roughly apply to pipe, except for with pipe we don't have a 3 and 4G because everything's, you have 1G, well you have to weld all the way around the pipe, right? So you have a 1G, you have a 5G, and a 6G. That pretty much covers everything. So another big thing is you have a lot of things going on when you're stick welding. So you have your work angle, travel speed, and your amperage. So the easiest thing to think about is CLAMS, C-L-A-M-S. If you can remember that acronym, this current, length of the arc, or how close that the end of your rod is to that puddle, or angle. So you have travel angle and work angle. So I usually run about a 10-degree work angle. So as I'm going through the joint, I have a 10-degree lead, meaning the back side of that rod is 10 degrees further than the tip of it. And then you have your work angle. So that is where in reference to that joint you are. So for the first pass, especially for multi-pass welding, I'm usually 45 degrees into that joint. Now as we go into the 4F position or overhead, I'm going to drop that angle just a little bit. And I'm going to focus more of my heat on that top plate, right? Because I'm going to use gravity to my advantage. If I run right at 45, I'm liable to get less material, less weld material on the top plate and more on that vertical plate. Okay, so if I drop that angle a little bit, focus more of my heat on the vertical part, it's naturally going to flow into that bottom or that vertical leg of that plate. And then M is going to be your manipulation. So if you have to oscillate a little bit, I'm not a big fan of weaving. I know a lot of people like to weave. If you want to weave, that's fine. If the welding procedure says you can weave your heart out. But for most applications, I prefer just to run straight stringers, a little bit of manipulation. When I get into overhead, I make tiny little circles. Okay, that's just my preference. That's kind of how I was trained. That's what I prefer to do. Just make little circles, and I pause at the top. Kind of like hitting a roller coaster. You kind of go around, there's that slight pause before you whip back into it. Same thing, I do a slight little pause at the top, and then whip back down. And just continue that motion throughout the whole piece. Everybody has a different style. Some people prefer to just drag the entire thing. One thing I highly recommend that you don't do on low hydrogen electrodes is you don't want to do any whipping and pausing action. So everybody's familiar with whipping and pausing. Leave that to the 6010 electrodes because you have to whip out so that puddle can solidify before you tie back into it. With 7018, it's a drag rod. 6010 is a work rod, so I actually have to work it. I have to whip that rod in there. 7018, just a straight drag, slight manipulation, slight pause, just a little bit of side-to-side action. Now when I run 3G or 3F, I do a little half moon shape or like a little U shape and just kind of pause on the side, very small, and I'm only operating the area about the diameter of a pencil. So if you've ever seen a pencil eraser, that's about the area that I'm operating in with a 1/8 electrode. And once I get done, that bead is roughly 1.5 times the diameter of that weld. So 1/8 inch rod, I should yield about a 3/16 wide welding stringer. Okay, and I'm just going to keep running multi-passes. Good? Okay, so it looks like she has the overhead portion done. So go ahead and clean that up. So did you guys notice at the amperage on the front of the machine that it remains nearly constant? So she's probably bumping between, I don't know, 116 to 120 the entire way. But if you pull back too far or get in too close, your voltage, you're going to see dramatic spikes in your voltage. You can tell, as anybody, a welding instructor in here? 1, 2? Okay. So watch your students. Between what you're hearing and what you're looking at the front of the machine, you can actually tell if they're doing relatively decent behind that welding curtain without even drawing it back. If their voltage is nearly current, or if their voltage is nearly constant and their amperage is nearly constant, they're probably doing something correct. And if it sounds correct, right? I don't let my students weld with headphones in, okay? They're like, oh, Mr. Becker, I need to wear my headphones because I get into a little rhythm and I weld better. No, you need to be able to hear the difference. Okay, so just to mess around because we got a little bit of time to kill, I'm going to switch Andrea over to DC straight polarity with this electrode, and you're going to be able to hear the difference. So to use anybody students in here, kind of figured. So we'll go ahead, we're gonna switch the polarity so you guys will actually be able to hear it. I don't even have to see what she's doing back here. I'm gonna be able to hear the difference. You can go ahead and run it in flat if you want. Just want to be able to hear the difference in it. So we'll go ahead and set it at the same amperage, and you'll be able to hear immediately the difference. You hear the difference, you hear how it's a lot more choppy. It's not as smooth as it was before. That choppiness right there, I could walk down in a bay of 10 welding booths and say that individual behind that curtain is not running the right polarity. I've been able to do it on job sites. You should be able to identify that sound. It's a very distinct sound. We'll go ahead, we'll switch this, we'll switch it over to AC if the machine will let me do it. You good? So now with AC, I'm getting 50% of that current on both sides, positive and negative. They're looking for you. Okay, this one won't let me do it. I'd have to switch it over into a TIG mode and use the foot pedal to be able to do that, because if you have a multi-process machine that's meant for DC, it's only going to allow you to run DC for your stick applications, but you'll be able to hear it because that arc is actually switching back and forth between positive and negative about 60 seconds or 60 times per second. It's going through that negative and positive cycle. So if any of you guys have one of the old school machines at the house that only runs AC, you can still run 7018 pretty effectively. So what allows that to happen, you have to make sure that your welding rod has one key ingredient. Anybody know what that ingredient is to be able to run on AC? No moisture? No? Bananas. It has potassium in the welding rod that's going to allow me to switch from AC to back and forth between those cycles, because if it does not have potassium in there, as soon as it goes to switch cycles, that rod's going to snuff out. You're not going to be able to use that. So make sure that the rod contains potassium, or it says it's rated for AC. Now, if you guys don't know, ESAB has free filler metal books, okay? If you guys run ESAB wires, electrodes, all that, and they're gonna give you good applications to use those electrodes in. They're gonna tell you good places to start as far as your amperage and polarity. There's just a lot of good information in there for their flux core wire, solid wire, TIG filler metals, all that good stuff. So I highly recommend, if they have them sitting out on the tables, go ahead and snag one. That's free information and good reference material for your toolbox. So inside your toolboxes, you should have stuff other than chipping hammers and wire brushes and welpers and tape measures. You should have reference manuals to refer back to. If you guys are anything like me, I run multiple processes all the time throughout the year, and sometimes I get stumped. I'm like, I know where that information's at. I can't remember it, but I know where that information's at. I can go back to that book and refer back to it. Like subarc, I probably do subarc maybe twice a year. I can't remember exactly what those settings are, they're gonna be, because I don't run it often enough. But I can go back and refer to that book, find out the type of flux that I'm supposed to be using, the type of wire that I'm going to use for that application, and how to get the amperes that I'm going to need. Okay, so this pretty much concludes the class. Do you guys have any questions? No? All right, well, if you guys are done, I appreciate you guys coming out. Hope you enjoy the rest of the show. If you have questions you want to pop up and ask, no problem. Thank you.
BOHMAN. Generamos mejores formas de fabricar tu mundo.